Good afternoon, everyone. So I'm Mark Roberts. I'm a solution architect at Red Hat. I was going to start with a reference to the previous session on CockroachDB, and I thought George Best was on screen, so let's start with a quote from George Best. Let's not start with a quote from George Best. That's not a very good place to go. There aren't many George Best quotes that you could politely use these days. So let's get straight to it. So this session is on GitOps and OpenShift pipelines. And our objective really here is to create automated build and deploy pipelines. That's quite simple. And I've been doing CI/CD stuff for many years with many different technologies. And it's a fairly simple objective, is to create pipelines and processes where we can smoothly create software and get it deployed quickly and easily. So if we add to that some of the GitOps principles, what this leads us to is that we want a system that is described declaratively. We want everything written down in how this system is going to operate. We don't want anything left to chance. We don't want anything left in a scripted guide somewhere that someone has to follow. The desired state needs to be stored versioned within a Git repository or a Git-like repository. Store everything in source code. I first started using that phrase back in 1996 when I bought a product called ClearCase, if anybody remembers that. Fabulous piece of software. I then went to work for Rational Software for many years on that technology. Fabulous stuff. But the world is now Git, and that's what we operate within now. Now, we need some way to approve changes, and we want to have those changes automatically applied. And that's one of the areas where systems can start to jar a little bit with people, because we like to have some sort of human intervention in these processes. So really, with the word automated in that part there needs to be something that we control with that approval process. And that's where, when we're thinking particularly about production environments, we start to think perhaps around ServiceNow tickets that get approved and integrations into those types of technologies where we can have some human intervention. We also want a reconciliation loop so that any fingers in the tinkering that takes place within a production environment is immediately identified and reconciled back to the common state of affairs that we have within a Git repository. So we have a single source of the truth within our environments, so that there is always the common set of assets that we want are deployed. So we extend our objective now to create an automated build and deploy process in which the assets are stored in and managed in a Git repository. They are stored, they are versioned, we have a history, we have an audit trail, we know who has changed what, where, and when. So in simple terms, we want to take our source content and we want to convert that into something that we can run. So we start off with application source code, so we have there on the left-hand side of the graphic, and we're going to go through some sort of compilation process to convert that into something that can run, and we're going to run that within a container. So we'll create a new container image, and we're then going to deploy that container image. Now, when we deploy the container image, we're combining that with the various different Kubernetes resources that describe how that application should perform. So we have two different sets of source content that we're managing here, really. We have the application source code itself, goes through some sort of compilation process. We have the Kubernetes resources that we're going to actually use to deploy the application into a production environment. So let's focus first on that continuous integration activity and the process that we go through there. So we're going to store our source code within a Git repository. And that initial step there, that store, is really the Git push action that all our developers are going to do to combine their efforts together into source code held within a Git repository. Find the clicker in the right place. There we go. So we then go through a build process. Now that can be whatever type of technology you want. In the demonstrations I've got that I can show you later on in the afternoon or in the session later on with a beer, happy to show you this running on my machine within an OpenShift environment. But the build process I'm using is based around OpenShift pipelines, based on Tecton that we'll come to in a moment. But you can use anything you want for that particular process. And that will pull the source code from the Git repository, and it will then go through a build process, and it will create a new container image. Now, that container image then needs to be stored somewhere. So we're going to put that in a registry where we can get access to it to deploy it from our environments. So we've gone from source code to a running container image. We've gone through some sort of compilation build process, and we've combined that with a base container image. Now, we could talk about that base container image for most of the afternoon, because where do we get that from? How are we managing those base container images to ensure that they don't have vulnerabilities in them? Well, again, that's something we can talk about a little further over a beer if you want to later on. So we're then going to move on to the continuous delivery phase. And in the continuous delivery phase, well, we start off here with the deployment configuration assets. That's our deployment YAML file, our route, our service, persistent volumes, config maps, secrets. All of those resources are held within there, and we're going to version those within a Git repository as well. We're going to store those in Git. And then our deployment activity is going to start off by pulling those resources from that Git repository, and we are then going to create the various different Kubernetes resources. Now, when we do that, when we create those Kubernetes resources, our deployment YAML file has a reference to our container image that we built previously. So we're going to pull that container image from our container registry, and then we're going to deploy that out and get a running application. Fabulous. So at the moment, we've been talking about some fairly abstracted operations that we're going to go through. What's the technology that we're actually going to use to make this happen? Well, the first one we're going to talk about is the OpenShift GitOps technology. Now, this is based on the Argo CD open source project. It's delivered as OpenShift GitOps on the OpenShift platform, fully supported, managed, maintained by Red Hat as a first-class citizen running on your OpenShift environment. It operates this declarative model in which you define what resources you want to exist within a Git repository. You then point your Argo CD application at that Git repository, and you tell it where you want that to deploy. So it basically says, what content have you got, and where do you want to put it? It's as simple as that. And then it maintains those resources on that Kubernetes environment, keeps them in synchronization. If someone tinkers with that environment, Argo CD will spot that, and it will reconcile it back to how it should be. So we don't get any of this configuration drift anymore. Everything remains exactly as it should. Really quick and easy to install onto your OpenShift cluster. As an operator, you require some elevated permissions to do that. It's not something every developer would be allowed to do, but it's really quick and easy to install. The next technology is OpenShift pipelines, with the cutest little icon there is of any open source project, it has to be said. I've called that Flo, that's my cat, and I've adopted that. I do have a black cat, so she needs a suit of armor because she's a real wuss. The birds beat her up in the garden. So that's what my cat really needs to look after herself. But anyway, OpenShift pipelines, it's based on the upstream open source Tecton project. And again, installed as an operator on your OpenShift cluster, really quick and easy to install. And it's a fabulous declarative continuous integration process. Whenever I speak to large organizations, and I'm sure a number of them are represented here today, one of the things they complain about is Jenkins sprawl. Now, I'm a fan of Jenkins. I've used it for many years. It's great at what it does, but it's an infrastructure headache for a lot of large organizations to maintain. There's a lot of moving parts to that to keep it up to date, and as a consequence, lots of people are looking to alternatives. So this is completely serverless technology, effectively. Some of you might have heard of serverless that we have that runs on OpenShift. That's another presentation, we could talk about that. This operates in exactly the same way, because you only run anything when you actually have a pipeline to run. Every individual pipeline runs in an isolated container, such that you get complete clarity over every instance you run. There's no other content hanging around to pollute the environment and cause issues. It always runs afresh every single time. So every action you perform, every task that you run, runs in an isolated pod. So again, delivered as an operator, really quick and easy to get installed and get up and running. Excuse me. So let's join the two things together, and let's create the CI/CD process on one diagram. So across the top there now, we've slotted in the Tecton icon there as our build process. That's creating our container image. That's pushing that into that container registry to be used. Now, the container registry there at that point could just be the OpenShift image stream, because at this point, we actually want to do some analysis on this to make sure that this is vulnerability free before we move it to our enterprise registry, such as Red Hat Key. So at that point there, we are creating a new container directly in the container registry. Now we'll have a webhook operating on here as well, such that as soon as an action is performed in Git, such as a push of new content, that will operate a webhook, that will trigger the Tecton build to run on the OpenShift pipelines, and that will cause a new build to run automatically. So all the developer has to do is push the source code into the Git repository. That will trigger off everything else that happens, and the result will be a new container image is produced. Now we bring in the continuous delivery phase there, and we've slotted in Argo CD there to provide our deployment automation process to synchronize all of this together. Now, that's going to perform an image pull, and it's going to pull that container image from the container registry into our environment to run it. But what's it going to pull? Because every single build generates a brand new container image with a brand new container image tag. So how does the bottom line then know what to use? Because it's one continuous process, and the new tag has been produced as part of that build process. So we have a step we have to go through here where we have to perform an update. And the red dotted line there is our build process updating the assets that we have to configure how we're going to deploy our application. It's telling it which particular container image tag we want it to deploy. And that's the next part that I want to talk about. So here I'm going to introduce a new technology to this process. It might not be new to everyone in the room, but I'm going to introduce Customize. Now, Customize is great at managing the configuration of the Kubernetes resources that we want to use as part of our deployment. We have a step called Customize Build, and that will generate a set of Kubernetes resources based on a particular template. So let me show you what that would look like in terms of a template. So here's our base deployment file. Now you can see from there, it's a deployment resource. It has a name called MyApp. It has a namespace, and it has a specification specifying the number of replicas there to be won. Now obviously that's a cut down version. It's not complete, doesn't have everything in there, just cut it down to make the slide look a little bit easier. So what we then have is a customized file. Now that might look a little bit involved, but actually if you break it down just like any other YAML definition, it's quite straightforward in that this one at the bottom refers to a location. So we have a section called bases. That references a particular directory location that contains the assets that we want to deploy. So in that location /base/main, I have my deployment YAML on the left-hand side. I have my root, my service, my persistent volumes, lots of other resources. Now this patch section there at the top is going to pick out a target. The target, as you can see, matches the file on the left-hand side, and it's going to perform a patch operation to it. And it's going to replace specification/replicas. It's going to replace the value 1 with the value 4. So when you read through it, just like most YAML, it's not actually that complicated. And the result will be that it will produce this new file. And the new file is just the one on the left, slightly modified. Now that's great because this allows us to create a base set of assets that are applicable to all environments, and then add the tiny little bits of variance that we have for specific environments. And you can probably think about lots of ways that this could be useful in other areas, perhaps database connections that you need to maintain, integration points that are different in different environments on the route to live. Now this is particularly useful when it comes to our CI/CD process because we have an ability to edit an image tag with a customize command. And this is something that we can build into our CI/CD process once we've produced this new image tag that we are going to use. So we start off with the file as it is on the left-hand side there. That's my customized file. Then I'm going to execute a command as part of my CI/CD process. And that's going to be customize edit set image. And then it's going to have an image, full name and tag on the end of it. And that will add this content to my customized file. It's not modified my deployment asset at all. It's not operating anything like sed or any other sort of editor to modify the actual deployment file. What I'm modifying is the patching mechanism that will be applied to my deployment files. And the result is that we have this images section that's added to the customized file. It identifies the name and it identifies the new tag that should be used. So now, when I use this customized file, that will be applied. Now, there's two ways that I can operate with this particular customized file. I can either use customize build, and that will generate a new set of YAML files which I can apply, or I can actually use just the OC command. The OpenShift command line interface has a switch, a -K switch. So some of you are familiar with using OC apply, -F, and then a file name that you want to apply. Swap the F for a K, OC apply -K, and then a location, and it goes and looks for a customized file. And if it finds one, it's then going to process that customized file. It will pick up the resources that are identified. It will apply any patches that are included in that customized file, and it will insert the container image there into the deployment YAML file, which is great. That's our patching mechanism. That's how we get things patched. Now, by doing this, I can then commit this version of my customized file to my continuous delivery Git repository. So it's baked in stone. It's an audited change. We've got it preserved forevermore. But of course, I've made a change to a Git repository. And what does that do? That kicks off operations in Argo CD, because Argo CD spots that something is new and different. It goes and applies that change for us. And that's what we'll look at now. So right over there on the left-hand side, we've got our development process. And we're starting off with cloning the source code, building a jar file in this instance of the application, and creating my runtime container image. That's my runtime container image with my brand new tag. I update and commit my customized file within my development branch or my development directory of assets, and that will then cause Argo CD to trigger its deployment operation. So brilliant. I've used a Tecton process on the left-hand side. I've used an Argo CD process there to update my deployment. Then we bring in the QA process. Now QA will start off simple here. We're going to update and commit my customized file for my QA environment. Now I'm doing this within my continuous delivery repository, within a Git repository, and I'm doing this actually on a QA ready branch. I'm going to bring in one of the other GitOps principles, which is that we should use pull requests as the mechanism by which we can review changes. And then by merging that pull request, we are accepting that change. We are merging that to a branch which is observed by Argo CD. Argo CD will pick up those new changes for us. So let's see how this pans out. So we create the pull request as part of our automated CI process. That pull request will then merge those changes to the main branch. And then, clearly not got this clicker in the right place. There we go. I can review the pull request, and I can merge the pull request. Whoops, I go too far. And that causes Argo CD to pick up those changes from my QA activity and deploy those out. Now that's the simple view of the pull request. Create the pull request, review it, merge the changes, Argo CD picks up the change. Sadly, it's a little bit more complicated than that. There's a few more moving parts to it. So now, I move that to the top of the screen because there's extra things I want to add here. And this is where I want to add in my security analysis phase. So I'm going to do an image build check. And my image validation is a gate point. It's in red. If I fail my image build check, if there are vulnerabilities found within this container image, we go no further. We don't go further than that point. But assuming my vulnerabilities don't exist and it's a clean image, I update and commit the customized change to QA, and I generate the pull request. Now it's a new commit. I've made that change within that particular QA-ready branch. It's a new commit, and I set the commit status to pending on that particular commit. Now that does something special in Git, because it stops you from being able to merge the pull request associated with that commit. So effectively now I've put a blocker on the merge process. We can't accept this change at the moment. What we're then going to do is I'm going to clone those resources into a new directory. I'm going to clone the content that is associated with that pull request. I'm going to configure my deployment assets. That's where I run my customized build operation. And then I'm going to do a resource deployment check. I want to validate those Kubernetes resources pass our security standards. It's not just good enough to look at the image itself, the container image, to see if it has vulnerabilities. We can shoot ourselves in the foot at the 11th hour with the resources we use to deploy this. Are we exposing any secrets that we shouldn't? Do we have resource constraints on CPU and memory for how we're going to deploy this application? Because if we don't, there could be problems. We might have a rogue pod that decides to run away with one of our worker nodes completely. Could cause all sorts of trouble. So there are things that are best practices, there are things that are critical to the vulnerability of our application. So we use advanced cluster security to perform that resource deployment check in the same way that we use advanced cluster security to perform our image build check at the top. And that's another gating point. We don't go any further if that fails, but assuming it's successful, we then set the commit status to success on that commit. And that allows that merge operation to take place. So what does this look like in reality? Well, this is me not being brave enough to do a demo on stage in front of such a large group of people and being constrained on time. So partway through our process, we've completed the stage of creating the pull request. We've completed the stage of setting the commit status pending. That then puts this little orange circle of pending indicator on the commit. It also means that that's grayed out. You might not be able to see that, but it says merge pull request in dark red on black, and it's effectively grayed out. Okay, it's dark redded on black, and you can't run that. So let's fast forward and complete all of the other operations successfully. We now set our commit status to success, and we get the little green tick, and the merge pull request becomes available. So that's the whole process in operation. That's what developers see. This is what people who are going to merge this pull request will see. So let's move this forward a little bit now, and let's take that process that I've talked through in the center there, where we're creating the pull request, we're using the statuses on the commits, we're doing our resource deployment checks. I'm going to sort of factorize that out now and call that my QA deployment process. That's a sort of wrapped up process that I can use for this process. And then on my final slide, I'm now going to work that through and show where it fits in and how we extend this into production. So we have our development process going straight away across. We update and commit our customized file for development, no pull requests, straight away change on the main branch of that repository immediately causes Argo CD to pick up that change for us and push that change into development, because that's what we want. We want things to go through quickly in development. We then bring in the image build check, and we go into that larger box that was on the previous slide. That's our QA deployment process. Now, if that's successful, what will happen is we've got that new commit with the merge process carried out, committed into our Git repository. That will trigger Argo CD to deploy into our QA environment. Now, after that image build check takes place there, if we're happy with the image, I'm going to push that to my enterprise repository. I'm going to push that to key, because if it passes the image build check there, it becomes a candidate image that could go forward into production. So I'm going to push that image to my container registry in key. Now, key is great. One of the things it has is webhooks. So the result of pushing a new container image into key can get key to trigger a webhook. And what does it trigger? Well, it triggers a OpenShift pipelines process. It triggers a Tecton process again. That is an exact copy of that process we had for QA, but now it's operating on our production environment. And it's going to deploy into production. So it's operating on production branches. It can include, if we want to, any sort of call out to something like a ServiceNow environment and create tickets in ServiceNow that need to be approved. There's lots of other wrappers you could put into that and extend that process. But in essence, it's a build out of that QA process. But it's triggered by the presence of a new container image in the key repository. What does that do? Ultimately, through someone's human intervention, there will be a merge operation taking place to merge the content for that production deployment after someone has done a human review of that content, and it will merge it in Git, and that will trigger Argo CD to deploy to production. So, that concludes what I wanted to show you this afternoon. I hope that's been useful. I will be around later on during the breaks and during the beers this afternoon. I am assuming there's going to be beers. You're not going to be very disappointed now if I've sold you that. And there's no beer when we get out there, so I think I need to go and figure that out. But I'm making a bit of a red hat assumption. So if anybody wants to talk about this further, then please grab me in one of the breaks, and we'll have a chat about it then. Thank you.